Good afternoon. Hopefully everyone had a nice lunch and perhaps you got out to see a little bit of sunshine. October tends to be that month. It's pretty good around Ohio for sunshine, but we'll flip that off here in about a couple of weeks and we won't see it again until April. Yeah, so again, my name's Aaron Wilson, and I'm going to talk about extreme weather in a warming world today. It's been sort of the backdrop, or what's been referred to in several of the talks already this morning, and maybe a little bit different tone or different feel than what we've already witnessed today. So, let's see. Oops. How are we advancing here? There we go. All right, so I am a weatherman. I am a meteorologist, and just want to give a quick backdrop or backstory to what brought me to this decision. So I was 5 years old, living in Miami, Florida, and my parents took me down close to Miami Beach to witness 30 and 40-foot swells of the sea when Tropical Storm Bob was coming up the East Coast. We didn't take a direct hit, but from that moment forward, I was interested in the weather, interested in what's happening with the atmosphere. And then we moved back to Ohio. So I was born in Ohio in a town called Miamisburg, south of Dayton. Moved back in 1987, and then the following summer we had the huge drought, the drought of 1988. Time magazine called it the Big Dry. Really fascinated with the weather conditions and what sparked this drought. And then many of you probably remember Dr. John Hope. He was the hurricane specialist at the Weather Channel. I stayed up days on end watching him as Hurricane Hugo came into the coast of South Carolina. I had a lot of family in Charleston, and so that got me interested in communicating the weather, and fascination with that. And I, of course, learned a ton of information from my parents about the Xenia tornado in 1974. And so ever since, I've been on this path to learning about weather. What I do now is actually expanded beyond just weather, but I also study the climate, and it's kind of also some more background information to what I'm going to talk about today. So we're on the West Campus of The Ohio State University, Scott Hall. I'm a meteorologist. I'm in the basement in a building that has very few windows. No windows in the basement, as a matter of fact. So that's forced me to use models to figure out what's going on outside, right? So I do have a lot of my professional experiences in polar weather and climate. Some fascinating things happen in the Arctic and also around Antarctica. But the one thing I've learned is that all of these cold regions, these places that we often think of distant from what's happening here, are in fact not that far in terms of climate. From changes that are occurring here. These areas are very connected, and so I'm going to explore a little bit about what weather and climate are to give the background to extremes. So I'm not trying to bring up any nightmares here. This is a MODIS image, satellite image showing snow cover a couple of Februaries ago. So we're going to we're going to talk about what are the differences between weather and climate. So this is a pretty simple topic, I think, but maybe there's a lot of subtlety here that often confuses the message when we're talking about weather, climate, and climate change. So weather is just that current state of the atmosphere with respect to the effects upon life and on human activities. And it's just caused by the physical imbalances across the globe between heat, pressure, and moisture. So because of the sun and the tilt and the orientation of the earth to the sun, we get a lot more energy coming into our system in the equator, less in the poles. The Earth's got to redistribute that heat. That's really the engine that drives our weather. So we're talking about short-term conditions, minutes to days, changes in the atmosphere. And this is a forecast actually from yesterday morning. We got a pretty good week ahead of us here. Temperature is above normal for a couple days and then a little bit below normal on the weekend, but nice and sunny this week. So get out there and enjoy it. So weather's what we see in the moment. It's what we can connect to. It's what we can feel and is around us every single day. And it's a lot easier to grasp onto. This is a mammatus cloud deck. Actually occurred over the Dayton Mall a couple of years ago. It's what leads to the beautiful sunsets. We've seen quite a few actually since August, September in this region. and even the killing frost and freeze we had over the weekend. So those are the weather conditions and the things that we're really in tune with every single day. All right, so what is climate then, and how is it different? Climate is the slower varying aspects of the atmosphere, but it also includes the oceans and the land surface systems. And we're talking about averages of the climate system, averages of these short-term weather conditions over periods of a month or more. And so this is a schematic, hopefully you guys can see, of some of the various aspects. When we talk about our climate system, we're not only talking about the weather variations that are occurring, say, in Columbus, Ohio, but we're talking about the amount of solar energy coming in, reaching the Earth, how much is leaving, the clouds, the cloud development, the interactions between surfaces, between the land surfaces and the ocean, all of the processes taking place between the surface of the ocean and the atmosphere. And when we talk about climate, we're talking about averaging all of these processes over certain periods of time of a month or more. And so it's a very complex system that changes, has a lot of moving parts to it, and trying to understand how those moving parts all relate to one another is what is behind the climate science, okay? So when we talk about climate and you see it in the news or you see it in the media, obviously we're going to go right from climate to talking about climate change. Global warming, that's usually what people they tend to avoid that term now, but hopefully I'll show you some images that I think global warming is completely appropriate here. But we look for indications or indicators of a warming world. And there are 10 indications that I've shown up here, and this is from NOAA, showing 7 factors that are increasing and 3 that are decreasing. And in fact, in a warming world, this is what we would expect to occur. So all of the ice, if you think about the sea ice loss, talk about the Arctic sea ice loss a lot in the media, it's decreasing. Our glaciers are retreating. The snow cover is decreasing, right? The things that are increasing that really impact, and we can see right here in Ohio, the temperatures over our land. The amount of water vapor, the amount of moisture in the air is increasing, okay? Sea surface temperatures. So if you're making decisions for your company along the East Coast, you got to be concerned about sea level rise. We know changes in the Greenland ice sheet and Antarctic ice sheet are leading to rapid sea level rise, and it's not equal across the entire globe. The East Coast of the United States will see sea level rise much quicker than most places on the globe. So if you're thinking about forward thinking in terms, the military is thinking about building the ports 50 years, where do the ships, where are the ports going to be located in relationship to the shore, and how much sea level rise do you have to account for? But just like most of us are really in tune with the day-to-day variations of the weather, climate scientists see the signs and are very in tune with even daily or monthly, yearly changes of our environment. So this is an example of chloral bleaching due to the acidification of our oceans. We see changes in the glaciers. Most of the glaciers around the world are retreating, and they're retreating very rapidly. If you're a person's living in the Arctic and you're dealing with permafrost thawing, you're dealing with degradation of your communities, of your households, of your livelihood. And we're already seeing these climate refugees from island nations and nations in the Arctic where their environment is being degraded. And we have climate refugees already now in today's society. So this part of the talk, I maybe get into a couple of graphs, and I'll try to simplify them as much as possible. This is just looking at the global land and ocean temperature differences compared to normal or average over the 20th century mean. So the average of our 20th century, and we're just looking at the global land and ocean temperatures back to 1880. And you can see compared to the 20th century, the late 1800s, early 1900s were colder than the 20th century mean. But then we see this rapid increase since about the 1980s here, 1970s, all the way up to last year, which was our warmest year on record, going back to 1880. And year to date, right now, this is where we are. This is through August of this year. So it's very likely that 2015 will now be the new warmest year that we have on record since 1880. But you're going to ask, no, wait. I remember last February, right? Last February, last winter, the winter before, absolutely terrible, right? And in fact, our weather was pretty harsh around here. If you're looking at last February's average temperature for Columbus, Cincinnati, and Dayton, ranked up there in the top 5 coldest. And you can see what the actual records are there on the right-hand side as well. Many days, we had many days below sub-zero temperatures in February, also way up there in the record books, and it was a quite snowy February as well. And there's some regional differences, so Dayton wasn't quite as snowy in terms of records, but certainly Cincinnati, nearly 20 inches, 18.6 inches of snow. So you're thinking, there's no way we're living in a warming world. Certainly not where we're living, right? But this can happen because we're talking about one area. We're talking about one state in an entire global map here. And you can probably pinpoint that out. So another example, we're talking about this summer. How many think it was a cool summer? All right. We actually were fairly close to normal, but right there on the line, this is Ohio here. So the northern part of the state was cooler. But when you can look at the entire globe and look at differences, what we call anomalies compared to averages, you can see most of the globe is red. It's warm. It's warmer than the average from 1981 to 2010. The sea surface temperatures out here in the Pacific, particularly here along the tropics, this is the El Nino everybody's hearing about right now. Okay? And undoubtedly this will impact our winter here this year. So I just want to play this video. This goes back to the late 1800s, and we're looking at 5-year means of temperature across the globe. And I just want you to look at how the color changes. So the blue cool colors that you see indicate that these were areas that had below normal temperatures compared to the 20th century mean. We have a little cool period here in the 60s and 70s, which most of you probably remember. And then since the 1880s, most of the globe is warming up. And you can see that it's really warm here across the Arctic, and you may have heard of the Arctic amplification. So this area is seeing drastic impacts to their environment because of rising temperatures. Just like to play through it again, but you can see if you just pick a point here in Ohio, you can see that we have warm temperatures and cool temperatures. So here we are in the 50s and 60s. It was cooler. Yet after the 1880s, the entire map just really, really warms up. All right. So how does this happen? This happens because I like this. You probably heard a lot of quotes about climate is what you expect, weather is what you get. I like this one, weather throws the punches, but climate trains the boxer. This is just a schematic showing this dog walker out walking the dog here. And we can anticipate where the dog walker is going based on what we see in the footprints. So the dog walker will end up somewhere up here. But it's a lot more difficult to track exactly where the dog is going to go. Maybe it goes up here to visit a fire hydrant. It goes down here and it visits some candy wrapper, right? And so you get these large variations around the dog walker, and we can call this our weather. The dog is the weather, the walker is the climate. So we know where we're expected to go, but we can see there's big variations in where we actually are in the weather. Most complicated graph I have up here, and then we'll get into a little bit of decision making here. So this is just probability of occurrence with colder than average, average, and warmer than average temperatures. You could just think of this as a normal curve, so you would expect your mean temperature here right in the middle. And what we've seen is we've seen our average highs, average temperatures, and average lows increase. So when you do this and you have a warmer environment, then the possibility of having more record heat goes up. Okay? It's sort of like, there's a good analogy today, as we've increased the amount of protein we've added to our diet over time, our height has actually increased. We've become bigger as a society. And so the ability to have taller people like me, I'm 6'8", has actually increased and gone up as well, okay? So it's a very similar analogy there. So it's not surprising then that our potential to have more record highs would go up, and that's indeed what's happened. We're outpacing our record lows nearly 2 to 1 at this point, okay? So this is just a line of evidence showing that the extremes are changing, and that's really what I want to get to, the heart of the talk today. So a lot of places like you've probably heard of the Intergovernmental Panel on Climate Change, probably heard of the National Academies of Science. They've put out these documents talking about the climate change. There was this document put out by the University of Cambridge on climate change, a risk assessment, and I think that's what this group is interested in. And the U.S. Water Alliance stated that they argue in this report here that the risks of climate change should be assessed in the same ways as risk to national security, financial stability, and public health, concentrating on what's the worst that can happen and how likely is that to be. It's about being prepared. It's about risk management and resilience, okay? So, but in order to find out what we should do, we need to look at what's happened, what's changed over our area. So I'm going to pull some information here from the climate change impacts of the United States. It was part of the United States National Climate Assessment. So we're looking at here changes over the past 22 years. So changes between the average temperature between 1991 and 2012 compared with the first half of the 20th century, 1901 to 1960. So here in Ohio, we've actually seen an increase in our temperatures between 1 and 2 degrees Fahrenheit. Okay? Not what's projected to occur, but this is what has actually happened here in our state. And you can see the decadal changes, so 1900s, 1920s, 30s, 40s, and so on, the amount of changes that we've seen over that time across the entire Midwest. And there are areas that are warming much more rapidly to the northern part of the Great Lakes than they are here in Ohio. So now we're going to go from what we've seen happen to what we project in the future. And this is where we have to start relying on models. Now, I'm going to be the first to admit I work with these models, right? They're tools. Many of you probably have tools in your toolkit to make decisions. They're not perfect. None of the tools are perfect. But we have really high confidence in the tools that we use, and I'm sure many of you are the same way. So what we look at are emission scenarios. We add so much CO2 to the atmosphere. What's likely to happen to our temperature based on the trends that we've seen and how we know that the climate interacts, the atmosphere interacts in the model. So this emission scenario is pretty much business as usual. You know, we have COP21 coming up. There are going to be some decisions made in terms of the amount of CO2 in the atmosphere and commitments from various countries. So if we just move along pretty much as business as usual, then between the period of 2040 and 2070, we're looking at temperatures between 4 and 5 degrees Fahrenheit warmer than we are today. Okay, and you can see some of these areas closer to the Great Lakes are much, much warmer than that still. Another indicator, the number of nights below 32 degrees, right? We're looking at 20 to 30 fewer days that we fall below zero. So we're decreasing, we're changing our winter season from middle of November maybe to the middle of March, cool period. Now most of you probably wouldn't mind having a little bit warmer temperatures, right? But these have impacts, big impacts on growing season, on the potential to have killing frosts. So maybe your average temperatures are warmer, your plants come out sooner. Then you get a big killing frost in March and April because they still happen. And so there's a lot of indirect impacts. It's just not a nicer environment to live in, but when we talk about extreme, you still get cold weather in a warming world. Okay? Now what about precipitation? This is, I think, what we'll maintain through the rest of the talk here. So this is the observed precipitation change across the country. Again, similar to the temperature. So what's the average between 1991 and 2012 compared to with the first 60 years of the 20th century? And so you can see the increases across Ohio are up to 15% more precipitation. That's back to one of the indicators of change I talked about, the increase of water vapor, the moisture in the atmosphere. It also goes back to changes in the jet stream. We know there's some scientific literature talking about how our jet stream is becoming elongated, so we get these big We get basically warm air surges up into the Arctic. We get these cold periods across the eastern United States. The polar vortex that we've actually saw a couple of winters now. Last year, not so bad. The year before, those are all tied to these kind of changes in our natural weather patterns, okay? So that was what we've observed, the 15% increase. Here in Ohio, we're looking at a couple more inches a year, right? So these are, again, the projected increases if we keep our emissions as we are now. We're looking at another 4 to 5 inches of rain per year. But this is a little bit misleading because this isn't a gradual trickle and adding rain as we go along. And I'm going to show you another graphic in just a second. But based on the temperatures and the precipitation increases then, what our climate, projected climate by the end of the 21st century, we'll have a winter climate sort of like the Delmarva or Virginian coast kind of climate. And our summers will be more like that of Arkansas, where we're much more humid, warmer, and this is kind of a good visual of how the climate in Ohio will change. And this has impacts on businesses, it has impacts on agriculture, and the whole ripple effect there. All right, so back to the precipitation a little bit. We're not talking about adding a little bit of precip to each month. What we're talking about is the intensity of the rainfall. Now this is observed changes in the heaviest precipitation events. Again, compared from 1991 to 2012 compared with the first 60 years of the 20th century. And we've seen here in the Midwest a 37% increase in the really heavy, intense events. This is what we've already witnessed. The Northeast off the charts here with a 71% increase. Okay, so we're talking about really heavy, extreme weather events that really impact the businesses and the decision making here in the state. So you go back a couple of summers, and you've seen these in the media, okay? And I want to make a really important point here, okay? I'm not claiming that one single event can be attributed to the climate change. But what we look for patterns and trends. And what we've seen are an increase in the number of these catastrophic or 1 in 1,000 year events. So a couple of summers ago, we had a string of them. Detroit flooded, okay? Wettest day in 89 years. And there's a lot of others. We've heard about the Toledo flooding. We've heard about Michigan flooding. The New York suburbs get an entire summer's worth of rain, right, in one day. Maybe some of you were aware that we had a 1 in 1,000 year event just east of Dayton in May of 2014. I drive this part of the highway quite a bit, and I was just astounded to see the pictures of the highway completely covered here, I-70. So we're looking at these increased events of these really heavy precipitation events, and again, that's back to the increase in the water vapor. A couple have already mentioned a few weeks ago the impacts of the flooding in South Carolina and some of the decision making that was going on. So a lot of areas actually saw above 24 inches of rain in just a matter of 4 or 5 days. So what are you going to do with all of that water? How much water is that? I like this infographic here. It's 11 trillion gallons of water fell in 5 days across the Carolinas. So if you took Lake Tahoe, right, you'd fill up a third of the volume of the entire lake in 5 days. 131,000 Rose Bowls filled to the top. How do you what decisions do you have to make to help mitigate the impacts, keep employees safe, keep things going in terms of the businesses? And certainly it was enough water to end the California drought. So I wanted to kind of move this into the last part of the talk here, talking about everyone is well aware of the toxic algae problem in inland lakes this year in the Ohio River, right? And a couple already talked about the water crisis that gripped Toledo last August, okay? But I want to use this in terms in a framework of making decisions here. So there's the Great Lakes, trying trying to remember, GLERL. I'll just leave it at that. Part of NOAA. Okay, so they're making forecasts for the toxic algae bloom that they expect. And they did some early season projections. Obviously, this is a lot dependent upon the loading of the nutrients into the rivers in the springtime. Many of you probably are aware of this and know this. So this was this year's projection on May 9th. Okay, so the wide bars here is the likely range, and this is their bloom severity index. So how severe is the bloom expected to be this season? This was for the past summer here in 2015. This was the likely range projection on May 9th. So let me go to July 9th projection here, and you can see that the likely range was well above what was considered the max potential in May. So many of you know what happened between May 9th and July 9th. We had extreme precipitation here in Ohio, okay? So this is comparing the amount of rainfall that fell in each of the states for the last 121 years on record. And indeed, Ohio had the wettest June on record. This was in June of 2015 for this period between 1895 and 2015. And if you look even closer, we can look at climate divisions. We have 10 climate divisions across the state. And right here along the Maumee River Basin, their wettest June on record in the last 121 years. So it's no surprise then that the projection for the algal bloom was increased drastically between May 9th and July 9th. All right, so I'm going to end the talk with just a couple of references that may help future decision making, decision planning for this partnership. There's a lot of good resources you can find online. The U.S. Energy Sector put out vulnerabilities to climate change and extreme weather. The CDC has a lot of information about climate change and health. The Department of Defense has a document on security implications due to climate change, and all of these you can find online, free. So some takeaway messages then. Again, climate is what we expect, but weather is what we get, and that's really the bottom line, the differences between the two. We've seen increasing frequency of extreme weather events, and this is a clear sign of climate change, and we've seen it right here in Ohio, here and now, okay? And the increased intense precipitation events, these are our most likely danger hazard moving forward into the future here. From a meteorologist standpoint, I think weather and climate should influence how we plan. So I think of it this way. Climate change really is the backdrop to long-term planning. How are things likely to change in the future? How should we make decisions that are going to best mitigate the danger as well as build a resistance to? But we have to be aware of this extreme weather, okay? These extreme changes in the weather which will take swift action. So there also has to be some planning, some plans that have to be implemented, I think, on a short time frame. And again, I think with I heard this morning with the 472 project, I think it's a lot of the things that are happening here. And we've already seen evidence of responding to these extreme events. So that's all I have for you today. Yeah, I'll take a question or two if anyone has one. If you have some question come up later, my email address is wilson.1010@OSU. Feel free to send me an email, and I'll answer any questions that you have or direct you to some information. Yeah.
We've been in a, I guess what you might call a quiet period for hurricanes for some time, maybe 10 years. I know hurricane is not a huge threat here in Ohio,
Mm-hmm.
but it is certainly to the East Coast. Can you offer any explanation for why we've sort of been in that 10-year or more quiet period?
Yeah, I mean, the easy answer is weather's very variable. I mean, there's a lot of obviously going on when you talk about attribution of climate change to the changes in hurricanes. We've certainly seen the most intense hurricanes increase in frequency. But in terms of what's happening with the Atlantic and over the last 10 years, it's not really an area of specialty, but right at this point, I would be willing to say it is climate. It's just variability over shorter periods of time. The 60s, 70s, and 80s, looking back at the records now, seem to have been a very active year or active period for hurricanes. And of course, really great measurements of hurricanes, frequency, intensity, really came along with the development of satellites and being able to watch these products, right? So looking at how many storms occurred 100, 200, 300 years ago, I don't think we have quite the handle on. So I guess we're missing a full piece of frame of reference for hurricanes, because we started monitoring them really well since the satellites in the late 70s, but even before that we had some idea. That's the best I could come. Yep. Yeah.
Dr. Wilson, so there's a predicted El Nino.
Yeah.
What's that impact for Ohio?
I was hoping someone would ask that. I'm actually an El Nino. I would consider myself, El Nino is the topic I love the most. 9 out of 10 years, El Nino brings dry conditions to Ohio and certainly the Midwest. Its relationship with temperature is a little bit more convoluted. There are years where we have colder seasons or warmer seasons, and that has a lot to do with what happens in the Arctic, other climate modes that we look at. But certainly with this El Nino and it being close to as strong or as strong as the 1997 event, I've been telling people it's going to be a pretty dry. I think we're already seeing the dry conditions. You know, we've actually been dry now for a few weeks, even though we had a fairly wet summer. I think we're already seeing the impacts of the changing jet shearing because of El Nino. We're starting to see more precipitation fall in California, Arizona, Utah. I saw some rain falling on that Utah game and was like, wow, it's raining in Utah. So they're going to start to break down and get a little bit of more rain out there, and that all has to do with the El Nino. So we know that here in Ohio, it's going to be dry. Temperatures, I'm a little less reluctant to say, yeah, it's going to be warmer. I know NOAA has their official forecast out, but every El Nino is different, you know. So we have this huge mass of warm water out in the Pacific, in the North Pacific, and I think it's going to influence the pattern just a little bit from what's typically seen. Dry. We'll be dry. Okay? Thank you.